Okay, so industrial heat. It's a huge challenge for factories, isn't it? I mean, a massive cost, and for so long, it's just been tied straight to fossil fuels. Trying to decarbonize that part of the energy picture is famously difficult.
It really is. Industrial boilers, they often run hard on gas or oil,
Yeah.
and that means, well, high energy bills and pretty significant carbon emissions.
Yeah.
It's definitely one of the toughest nuts to crack in this whole energy transition thing.
So what if, just what if there's a cleaner way, maybe even, more cost effective to get those high temperatures industries need for things like steam or drying processes?
That's exactly what we've been digging into today. We looked at a whole stack of sources, focusing specifically on advanced solar thermal tech, the kind designed for heavy industry. We're sort of unpacking the real benefits, the market situation, and who's actually making it happen, particularly down in Mexico.
Right. So our mission for this deep dive is really to zero in on the tangible plus points of this technology, thinking about systems like the XCPC Arctic Collector, and to see how it's actually moving from just an idea to being put into practice in Mexican industries. The sources, well, they make a pretty compelling case that this could be a bit of a game changer, starting with the absolute basic need,
Yeah.
heat. And we're not talking about just basic hot water here.
No, this is a completely different league. These advanced collectors, they're engineered to hit serious industrial temperatures. We're talking up to 210 degrees Celsius. That's over 400 Fahrenheit, and consistently too.
Yeah.
And the crucial point, the thing the sources really hammer home, is getting that kind of heat without mainly relying on gas.
Yeah, and it's fascinating how they seem designed for the real world of manufacturing. They can plug into existing factory systems, apparently.
Yeah.
And with thermal storage, sort of like a heat battery, right? They can keep supplying heat even when the sun's not out, which is critical if you're running operations 24/7.
Exactly, that continuity, it's just non-negotiable for industry.
Mm-hmm.
Another key thing, specifically about certain types mentioned, like the King collector, is how simple the design is. Basically, no moving parts.
No moving parts. Okay, what does that actually mean for someone running a plant day to day?
Well, it translates to significantly lower operation and maintenance costs. Think about it compared to complex high-temp solar systems or even just standard boilers that need constant looking after. It just simplifies the whole thing, makes it more reliable, and that's hugely valuable in an industrial setting.
Reliability, lower cost definitely sounds appealing. And the environmental side looks pretty substantial too.
Oh, absolutely. The sources estimate that each collector unit can avoid something like 4 to 5 tons of CO2 emissions every year. That's a direct cut in a company's carbon footprint just by switching the heat source. Simple as that.
And financially, the picture seems positive there too.
Yeah, the sources point towards a lower total upfront investment and much lower running costs compared to your traditional fossil fuel heat generation.
Which, okay, brings up something important, especially if you've got limited space at a factory. Efficiency per square meter. How does this advanced solar thermal actually stack up against other renewables fighting for that same valuable roof or ground space?
Right, and this is where some of the numbers get really interesting.
Sure.
Compared to standard PV solar panels, the ones making electricity, these high-temp solar thermal collectors can produce, on average, about 3 times the kilowatt hours per square meter.
3 times from the same footprint. That's quite a difference right there.
It is. But listen to this, compared to biomass or bioethanol setups, the sources suggest the energy yield can be up to, get this, 43 times higher per square meter on average.
Wow. 43 times. I mean, think about what that energy density means on a crowded industrial site. Getting that much more useful energy from the same limited space, that's a huge advantage.
Definitely. So you combine that ability to hit high temperatures consistently, the reliability, the low maintenance, and that really exceptional energy density. It makes this advanced solar thermal tech particularly well suited for what they call ship solar heat for industrial processes.
And what's really fascinating and maybe a bit surprising is that the sources highlight Mexico is already kind of leading the way in this area.
Yeah, it seems Mexico has actually installed more IPP plants since 2017 than any other country. So the market there is clearly, mature and actively looking for ways to cut those high energy bills and maybe rely less on fuel imports.
That suggests a strong pull from the market itself. And the sources also mention positive signs from policy, with solar heat actually being mentioned in national energy plans. So this isn't just some niche idea. It feels like it's gaining real traction within the country's energy strategy.
And that established market means the know-how, the expertise to actually implement these advanced systems is already there. The sources emphasize that this specific XCPC Arctic technology, the one built for these tough industrial jobs, is actively being introduced into the Mexican market right now through local specialists.
Specialists who really know their stuff when it comes to solar boilers and industrial heat systems.
Right. The material specifically name-drop Wastebusters Mexico, represented by Ruben Molina, as partners who can provide really detailed technical diagnostics. Basically, they can go in and show companies exactly what they stand to save, both in pesos and in CO2 emissions, by switching from gas or whatever they're using now to this kind of advanced solar thermal.
So getting a clear data-backed assessment tailored just for your specific operation. Okay, so wrapping this up. What we've looked at today, it isn't just some promising future tech. It sounds like it's proven. It delivers high-performance heat consistently without gas. It offers potentially significant cost savings, major CO2 cuts, and that really impressive energy density we talked about.
And critically, it's being put into action right now in Mexico by knowledgeable local partners who can give companies that vital technical assessment.
So when you put all that together, you've got Mexico leading in industrial solar heat. You've got this advanced XCPC Arctic tech arriving with clear, measurable benefits, and it's backed by specialists like Wastebusters Mexico. It really makes you think, doesn't it? What could this shift mean for the future of industrial energy, maybe even beyond Mexico, or maybe more personally for you listening? How could industries, perhaps even your industry, start exploring these possibilities and maybe leveraging these advantages that seem already proven?